All right, the last thing we're going to look at this week is some applications of vectors. So a force vector is going to be any vector that represents a pull or a push of some kind. So here's an example. Let's say that you're holding a package that is 10 pounds. There's two force vectors involved in that scenario. Gravity is trying to pull that 10 pounds to the ground. So it has a downward force of 10 pounds. Then you are trying to keep that package from crashing to the ground. So you are lifting, you're pulling it upwards with a force equal to that of gravity. That's how you're keeping it from falling down. Now you want to hold it exactly flat. You don't want to lift it too hard and send it crashing up into your face. So in this case, you are exerting an equal amount of force, F2, as gravity is acting on the package, F1. So the net force there would be the zero vector. If the forces are not equal, that's how we get it to move in one direction or the other. So in general, if you have two forces acting on an object, F1 and F2, the net effect is going to be the same as if just the resultant force F1, F2 acted on the object. So that's how you're always going to figure out the resultant force, is to add those two vectors together, okay? And again, if the object is not moving, then that means the resultant force is the zero vector. So here is an example that we are going to look at for this first one here. So it says, two forces, F1 and F2, of magnitude 10 and 30 pounds respectively, act on an object. The direction of F1 is north 20 degrees east, and the direction of F2 is north 65 degrees east. Find the magnitude and the direction of the resultant force and express the magnitude to the nearest hundredth of a pound and the direction angle to the nearest tenth of a degree. Okay, so we need to come up with the vectors F1 and F2 first. Once I know what those vectors are, then we can add them together by adding their A's and adding their B's. So let's start with F1. Now, remember, if we sketch, if we sketch these bearings out, we might have to do a little bit of work to figure out what the angle is. Now, they're both going northeast, so I'm going to sketch that like this. Here's north, and here's east. Okay, so F1 is going north 20 degrees east. That's F1. So right here is 20 degrees. That would mean that the theta angle we want is right here, and that is going to be 70 degrees. Okay, so we'll go ahead and make that note. Theta 1 is 70 degrees. Now, if we think about the next one, it's north 65 degrees east. Let me take these guys out of here. North 65 degrees east is going to be more like this. So if we subtract from 90, that gives us 25 degrees for the angle in standard position. So that's going to be theta 2 that goes with the second force, 25 degrees. Okay. So now, using what we know from the previous video is that any vector v is going to be equal to the magnitude times the cosine of theta times I plus the magnitude times the sine of theta times j. That's how we're going to get our position vector. So we need to do that for F1 and for F2. So let's start with F1. The magnitude of F1 is 10 because they told us so. And then we have the cosine of 70 degrees, I, plus 10 times the sine of 70 degrees, j. Vector. And then F2, using the second angle, F2 has a magnitude of 30, and that's going to be times the sine of 25 degrees, I, plus, that first one should be cosine, not sine. It's getting late. 30 sine 25 degrees, j. Now, I want the resultant vector F1 plus F2. That's what we want. So remember that in order to do that, I need to add these two components together. And I'm going to go ahead and put that in my calculator. 10 cosine 70 plus 10 sine 70. 10 cosine 70 plus 30 cosine 25. I want to add the two A's together. And using the calculator, I get 30.61 I. And then I'm going to do the same thing with J. I'm going to add the B component and the B component. And when I do that, I get 22.08 J. Okay. Now, again, this is something that I've been pointing out and people have been asking about. Notice that it asked us to give the magnitude to the nearest hundredth of a pound. 2 decimal places is what they want our final answer to. This is probably going to work out fine, but if you're worried about rounding, then maybe do 1 extra decimal on your intermediate steps and then cut it down to 2 for your final answer. But I think this is going to work just fine. So now we need to find the direction angle and we need to find the magnitude. Well, the magnitude is going to be just Pythagorean theorem. So we want the magnitude of F1 plus F2. Whoops. So that's going to be the square root of 30.61 squared plus 22.08 squared. And obviously that's not going to come out nicely. They told us to round this to the nearest hundredth. So that's going to be 2 decimal places. And putting that in my calculator, I get 37.74 pounds. The force is being measured in pounds. They told us that with the magnitude. So this one is also going to be in pounds. Now, to find the direction angle, we have to go back and use a little bit of trig here. So we know that F1 plus F2 is going in the positive X direction and the positive Y direction. So let's sketch a little picture of what that vector is going to look like. It goes about 30 on the X and about 20 on the Y, so maybe something like this. And so we want to think about this as a right triangle. So our horizontal direction is the A value, 30.61, and our vertical direction is the B value, 22.08. And the question is, what is this angle right here? So this is a different theta. You can call it alpha or something if you'd rather. Well, that is our right triangle trig. So I know that the tangent of theta is equal to opposite over adjacent. So 22.08 over 30.61. And to solve for theta, we need to do the tangent inverse of all of that, which comes out to, they said nearest tenth of a degree, comes out to 35.8 degrees. And so that is our direction angle. So that kind of puts all the things together. Magnitude, unit vectors, the direction angle, all of those things sort of combine into one problem. So again, we had to start by coming up with the vectors F1 and F2 using that angle. And then we used our properties to be able to add F1 plus F2, and then we could find the rest of the information. So there is one more example just like this one for you to try. So there's 2 tugboats that are towing a ship, and one is exerting 4,200 pounds north, 65 degrees east, and the other one is exerting 3,000 pounds south, 58 degrees east, respectively. So it basically looks like this. And this is why this idea of force is so helpful. We have like our big ship over here that they're trying to tow into the harbor. And you've got one little boat that's tugging this way and one little boat that's tugging this way. So even though these 2 vectors are different forces, the amount of force that's really ending up pulling that boat is going to be what we get when we add those two vectors together, okay? So I want you to go ahead and get started on this one. See if you can start by figuring out what the two different theta values are that you need to use. And we'll have that be kind of our pit stop. So before you get too far, the first theta is 25 degrees, and that's exactly what we did in the previous problems to come up with that angle. You just need to subtract it from 90. Now, the second one is going at a southward bearing. And so a bearing of south 58 degrees is that blue angle there. Now, again, we want the angle in standard position. I went negative because I thought that was the shortest direction to go there. And then the other option would be to go all the way around. So you could also use 328 degrees and you'll get the exact same answer. But working with negative 32 is a lot easier. So now your job is to figure out the vector for force 1 and the vector for force 2 so that we can add them together. So I will give you those answers in 3 seconds. Once we have F1 and F2, now we need to find the resultant vector F1 plus F2. And once we have that information, we now have the values of A and B that we need to be able to answer the two parts about finding the magnitude and finding the direction angle. And there you go. You should get a magnitude of 6,353 pounds, and you should get an angle of 1.7 degrees. And now you know all kinds of things about vectors.